Hey everybody, welcome to Cassandra Lunch number 42. And in 10 weeks, we will have a full year. I think we're probably close to a year. It's just we haven't done a Cassandra Lunch every week because of some reason or another. Today's topic is Cassandra Lunch, Cassandra with manipulating SSTable files with SSTableloader. If you're not aware of what SSTables are, you probably have never used Cassandra before. I'm just kidding. SSTables are basically where files are stored inside the file system, and it stands for sorted string table. And I'm looking forward to what OB has to discuss about that today. But before we get started, I am your organizer for this meetup, looking for folks to help out with this job. Gets you exposure to technology, but also people. We are part of a larger community called Data Community DC, which has many different meetups. What do we cover here? We cover all things Cassandra protocol, which includes the storage structure and retrieval and reading and writing using Cassandra query language, as well as in some cases, things that are not Cassandra that use those same protocols, such as managed key spaces, which is an AWS product, or Cosmos DB, which is an Amazon product, Azure product. So I don't know anybody new. Normally, if somebody's new, we pick on them to tell us hi. Group rules: if you have a question, just ask it, be polite, share what you know. Our company, Anant, helps professionals build scalable platforms, real-time platforms that run big company customer experiences or information systems using Cassandra, Spark, and Kafka. DataStax is a partner and a sponsor of the meetup. So is GW University for local events in DC, as well as a few other event venue sponsors, such as Waveable in Chicago and Eastern Foundry in Roslyn. Also want to thank the organizational sponsors that are helping the nonprofit known as Data Community DC. We have a Data Week event that's going to happen in September timeframe, which they're going to be funding the press releases for, and maybe by that time, if the spaces are open, they'll pay for a lot of the food and beer and soda. Do we have any announcements for any upcoming events? I know there's a few topics in the queue for Cassandra. I'm going to bring up. Yep, next week we're going to talk about DS bulk with Z and awk to basically do import-export operations with Cassandra. Great. And that's it from me. And without further ado, I'm going to pass it on to Obi, our speaker for today.
All right. Hello. Give me a second to share my screen. All right, so as you heard today, we're talking about SSTable files and SSTableloader in Cassandra. We're probably going to breeze through a good portion of this because talking about SSTable files is something that we've already done in a previous Cassandra Lunch on doing data operations with Spark and Cassandra via SSTable files. So there are a couple of those Spark projects that manipulate SSTable files directly and use that to interface with Cassandra, whereas this is about this Cassandra internal tool, SSTableloader, for working with SSTable files in Cassandra. Which means that we already have a decent explanation on SSTable files. We have a blog post up. We have an explanation in that other YouTube video on our YouTube channel, but we'll go over it here just in case. And because this will probably be a pretty quick thing to get through and we already have this information available elsewhere, there are specific questions about SSTables, about SSTableloader, and anytime during the presentation, feel free to just speak up. Let me open the chat in case comments come through there as well. So I will be looking at the chat, but it is also fine to just speak up in the Zoom call. So getting started with SSTableloaders. So what you've heard from Rahul already today is correct. It stands for sorted string table. It's on disk storage for your Cassandra cluster. The way it works is it's completely immutable storage. So once Cassandra writes out an SS table, it never goes back in and edits it and changes the data in there. If there are changes to your data, it just writes out a new SS table, and then during the read process, if there are potential overlapping data that appears in multiple different SS tables, the cluster just chooses the most recent one. There's a process called compaction in Cassandra that combines SS tables and deletes your duplicate data, so that you don't have to go through that process of comparing timestamps and choosing the most recent changes to your data. And then the actual SS tables on disk consist of a number of different types of files. So data.db holds the actual data. It's compressed down. Index.db tells you where it's an index from the partition keys to the positions in the data.db file. So you go into the index.db file, get a location in the data.db file, you go to that location and you get the data out. So if you have wide partitions, you might need summary DB to get more sort of an even higher level search tool. So rather than searching through the index.db file, you use the summary.db file to narrow it down and then go into the particular section where that data is stored. You also have your Bloom filter, your compression info, different metadata and statistics, and the CRC32, which is an error correcting code. So here we have sort of visual representations of those components, your index summary, your SS table index, and your data, and how those sort of relate to each other. And then SS tables in Cassandra reads. So when you do a read in Cassandra, the sequence of events that happens is it checks the mem table, checks the row cache if you haven't enabled, checks the Bloom filter to see if that data is there. I think the Bloom filter tells you if your data is definitely not there.
Sorry about that, guys.
Yeah, no problem. And then you go and get it from your SS tables if you need to. So it first checks the mem table, goes through a number of different sections of your SS tables, some of those other files, and then basically it's avoiding doing all the work of searching through your data.db file, which has all the data, and instead finding different ways to say the data is not here, or within this larger section, the data is in this smaller subsection. So you don't have to go through and search the entire thing. And then in the Cassandra write process, normal data is written to the commit log in chronological order, written to the mem table, and then eventually, either through just time passing or through manual flushing, it flushes data to the mem tables and it stores it on disk. It flushes data from the mem tables, sorry, to disk on SS tables. And then the compaction process, you have a number of SS tables with overlapping data. And then as SS tables accumulate in your cluster, compaction triggers. It combines those SS tables, keeping the most up-to-date data deleting data that has been deleted since then, and is marked in your cluster at that time by a tombstone. Okay, this is a section that was not actually in that previous presentation, but was part of the blog post for it. A blog post about SSTables that came a little bit later on. So when you want to look at your SSTables, it's not stored on disk in human readable format. Like I said, it's compressed. But you can use SSTableDump to view that data in JSON format, which you can see over on the right here. It has the key, it has the timestamp, it has your data, all the columns there, and the actual data that goes with it for every row that's in that SS table. And you can also use SSTableDump to view it in what's called an internal format, which you can see at the bottom. It's much harder to see just because of the scaling of that cutout. But essentially, rather than everything being spread out in full JSON format, it's a very sort of compressed format. It's still human readable if you take the time to look at it, but essentially it's just square brackets, column name, example of the actual data, and then timestamp as a list. So it's more compressed than the JSON format, but you can still get an idea of most of those things if you need to look at it.
Obi, I have one small query.
Yeah.
With respect to a stable, whatever the file you have shown. This data will be, that means if I access the SS table, I can see data in this particular format, or I need to export or something that is required to see the data in this particular format.
Yeah, if you want to see the data in this format, you need to use SSTableDump, which is a tool that is included with your cluster generally. If you just open the SSTable file, it doesn't look like this. You can sort of see some of the data depending on how that compression is actually done, and depending on how different your data is from each other. Like we will look at one in a second on my computer that will be able to see, say, one example of maybe each of the fields in that, because the different rows all have very similar, they differ by maybe a character or two. So the compression is highly efficient there. And you only need one example, and the others will all be compressed into something that isn't readable by humans. So SSTableloader, also known as the Cassandra bulk loader, is a tool that streams data to a running cluster. It is part of like standard Cassandra installations, also part of DataStax Enterprise. And it's interesting because it doesn't just copy your SSTable files to a cluster. What it does is it streams that data, places it on nodes that are consistent with the replication strategy and the replication factor. So if you're using vnodes, or if you're just using a normal sort of round robin replication strategy, it will put the replicas on the correct nodes and it will keep with your replication factor. If you want to use it, you will need your data.db and index.db from the SSTables at the very least, and you can load from snapshots as well. All right, so we're going to go through a quick demo, but first let's look. So this is an SS table. It is copied off of a Cassandra cluster that was running in Docker. And what we're going to do as part of this demo is run that cluster fresh with no data on it, and then use SSTableloader after setting up the table and key space properly to then load this data back in to the Cassandra cluster. But if we just wanted to look, you can see there's a sort of timestamp format here, sort of an email address here, but then other characters are just things that you can't really read because they're compressions of other data. Okay. So we have our two nodes up here. First thing that we're going to do is copy our saved SS tables onto that cluster. It is possible to run SSTableloader from just somewhere else. It doesn't need to actually be run from within the cluster by specifying the host name properly. But since Cassandra already has SSTableloader installed, we're just going to use it from within the cluster. So we have copied our files over. We're going to now open up a shell within that cluster. The first thing we're going to do is ensure that the table that the key space that we're about to create doesn't actually exist. So the table and key space you use for SSTableloader do not need to be empty. But in this case, we're going to have them be empty in order to ensure that the data isn't already there, that we're not just like faking the use of SSTableloader. And then what we're going to do after that is create our key space. Your key space does already need to exist, but if you want to load from a snapshot, you can actually use the saved table schema, because when you use snapshot, it saves that. So you can see here we have schema.cql. I'm going to use it to create that table, but you can also actually just look at it. It's just the definition for the table. So it does not define the key space. So the key space that you're creating needs to already exist. And then I'm going to grab everything necessary for SSTableloader. Here. So you can see it's in OptDSC resources, Cassandra, bin SSTableloader. So this one doesn't actually have the namespace defined correctly for you to just use SSTableloader as a command, but most of your Cassandra clusters, your manual installation should. Use -d and you define the host name, because what SSTableloader does is it goes to a single node in your ring and uses that to get data for the rest of the ring before streaming data onto your cluster. And then you're defining the location of your SSTable. So like I mentioned briefly earlier, the things that you definitely need are your index.db and your data.db. And you can also give it a snapshot directory and it will load data. Okay, that should be good. And if we go back into CQLSH, we should be able
Obi, one more query is there. Okay.
yes.
What I understand is now, since you are providing the one particular path, the in Cassandra, what happens is the data will be stored in different nodes, right?
Yes. So this uploads specific SSTableloader uploads specific SS tables. Because this is only a single one downloaded from a single node, we're not actually getting the full extent of the data we uploaded. You would need to go through each of your nodes, flush out SSTables, grab them, and centralize them. You
Yeah,
could write a
what?
script and then use SSTableloader to.
Yeah, so
to
one
move
one
those
quick
ones.
quick note to add is that when you run SSTableloader, you are restreaming the data, and at that point, if you're going to a cluster, even if the data doesn't belong on that node, it will redirect it. That's one thing to note about SSTableloader. It's just doing it in a more efficient manner than you just writing CQL statements. Okay. The other thing to note is that generally when we use SSTableloader, it's behind the scenes as part of Op Center. When you are restoring from a snapshot from one topology to another, so if it's not the same exact topology, the same exact number of nodes, same data centers, where you can just move the data back, Op Center behind the scenes actually uses SSTableloader in parallel across many machines. Does that clarify, JB?
What you mentioned with respect to snapshot recovery, you mentioned something, right? It is only specific when we are doing it for the key space strategy change, the
No,
replication strategy change.
no, no. Like, let me. I don't know where you're getting key space from right now. So SSTableloader.
Replication strategy, I'm saying.
Yeah, you can change the replication strategy on your destination. That has nothing to do with the SSTable. SSTable is just storing the data, right? If you make a change to your key space strategy and you use SSTableloader, you don't have to change anything from the SSTable. That's just pure data.
Yeah, the SSTable will conform to a new replication strategy or a new replication factor.
Yeah, and SSTableloader isn't doing anything, right? SSTableloader is just sending data to the cluster. The cluster is then deciding where the data goes.
Mm-hmm.
Understood. Yeah.
Okay.
You can see we've uploaded the data into our cluster.
Hey,
one more point.
Can I ask one quick question?
Yes.
Just to clarify about SSTableloader.
Yeah, go ahead.
So when you have an SSTable and you load it, it doesn't mean you're going to end up with another SSTable in the target cluster, right?
No,
SSTableloader is acting as a client, and it's just like you have a client which sends data. Rahul, you mentioned you stream data back.
Yep.
So it's like you have a cluster and you write data to your target cluster. Sorry, you have an SSTable, you write data to your target cluster, and it's the job of the target cluster to determine where that data goes. It has nothing to do with the original SSTable.
Yes.
Got it. Okay.
If you had two clusters that had the same topology, you could literally copy over your SSTable files and it would work. But SSTableloader doesn't do that.
Mm-hmm. Okay. Cool.
Yeah, and this is in one of our data operations guide, which eventually will make it out to the web. But SSTable can also be used for migrating data from one table to another in the same manner, right? So like, let's say you make a change to the clustering column or the whatever, as long as the column names are the same, it will work. So if you go from like, if you move a clustering column into the partition key, for example, right? Or vice versa, as long as it's using the same field names, you could stream an SSTable from one to another.
What I understand is if I can use the SSTableloader for the just say I'm creating a replica of the same table, and I can use that SSTableloader for copying the data to the replica table, right?
Yep. Nothing stops you from doing that. Yeah. You just make a different, I mean, basically like in this case, can you go back to your SSTable command, OB? I think you were showing it.
Which one? The SSTableloader command?
Yeah.
Up here. This one?
Okay, so that's the SSTable itself. No, the SSTable, when you're running the actual SSTableloader command.
Oh, wait, sorry.
There we go.
That is, right.
Yeah.
Here.
Yeah, let me double check something real quick. 1 second. That part I have to verify, JB, but I know that you can have the same name. So let me give me 1 second.
No issues. Just a clarification.
Yeah, no, it's a good question. It's a good question.
So is the question if you can upload the same SSTable into a different table?
Yeah, as long as it has the same schema, right?
Right,
Or as
okay.
long as it has the same field names. That's what I'm verifying right now. So 1 second. I have to get back to you on this one. I thought that I had seen something where like, yeah, maybe I was thinking along the lines of that you have the same table name, different schema, it will work. And yeah, I don't think, yeah, okay, so I'll take that back. So basically, if you have the same table name, different schema, same field names, just slightly different, that SSTable works for that, but I don't think it would work from going from like one table to another table name, because part of the, I can see why it wouldn't work, because part of the way the SSTables are storing data is that these are just column families, right? So because they're column families, the key or the column value is kind of tied to the table name in terms of how it's kind of storing all this stuff. But I'll dig in. And I'll let you know maybe in a future follow-up. Okay.
Hey, Rahul, a quick question. This is Sunny.
Hey.
So just to get the understanding right. So if as you mentioned, if the columns remain the same, even if in the destination, one of the columns was part of the clustering key or just a regular column, and if it becomes part of the primary key, as long as the column families remain the same, we still can use the feasibility of the SSTableloader, right?
Yeah, that part I think I've verified that. Yeah, that part I've verified. And I can even find an article. I think I read it on ScalaDB's site. But yeah, basically as a way to change a data model, you can use SSTableloader to move data.
Okay, but even if we add another extra column, or if the destination has some extra columns, in that case, this is not an option, or we cannot use.
Well, if it has an extra column, it shouldn't break, because it's fine. If it has less columns, I'm not sure what would happen. But if it has more columns, it doesn't matter, because it's just setting the data that's there, right?
Right. So the additional columns would have null data or something?
No, it won't have any data, because the way that Cassandra works is if you don't specify any data, it doesn't store anything. If you put null, then it creates a tombstone, and then that gets evicted at another point.
Exactly. But in case of lesser number of columns, probably that may create an issue, I believe.
Maybe we get warnings. It's worth a try. I'm trying to find the article that I read where it was explaining this. I think when we get the blog post published, by that point, I'll have a clear kind of reference point. I know that this is a way to move data. I'm just trying to make sure I'll give you the exact constraints. Okay.
All right. Thanks, Rob.
Did you, OB, have more? Or I think we kind of hijacked your presentation.
Yeah, no, that was basically it.
Gotcha. Yeah, the SSTable format itself has changed a lot, and it's become more and more efficient. And in Cassandra, the storage mechanism for SSTables, it's reflected in memtables, right? So everything that comes in gets put into memtables or commit log, and then it gets flushed to SSTables. But the SSTable idea is not unique to Cassandra, right? SSTables are used in a lot of different databases. So it may be a slightly different format, meaning like how Cassandra uses it, but like RocksDB uses SSTables, Bigtable uses SSTables, right? That's where this idea came from. So it's going to be different for different databases, but the idea is the same. SSTables, what they do is they enable fast writes of data, and as data comes in, it gets appended and it gets appended and it gets appended, right? And then over time, it basically merges it, and that's called compaction. So these concepts were inside the original kind of Bigtable paper, right? I'm going to bring it up. Let's share it on the screen. Nope, no, that's not it. Am I even on the right machine? That's the question. I'm on so many different machines these days. Here we go. I found which machine I'm on. All right, yeah, so basically like, we're talking about the, go up at the top here. This is the Bigtable, just notes on the Bigtable, this storage system, and it stores things as strings, right? But the way it distributes is through this kind of like hash table method, where in Cassandra is slightly different. But if you look for SSTable, here it is, right? Data is too big for memory. So what does it do? It appends it to SSTables, and they get merged. This is still inside Cassandra, right? Because Cassandra came from a lineage of Dynamo DB and Bigtable from those papers. And Bigtable to this day still uses SSTables. So that's just a little bit of trivia. Let's see, there's a question. Yes, JB, key space to key space works. Yeah, exactly. That's definitely true, because you're just in a different key space. Cool. Any other questions about SSTables? Oh, great. And I think I mentioned this before, but there are some clients that I've worked with that use the SSTable writer and reader. So what they'll do is they'll take a snapshot of the Cassandra cluster. They'll move all of the SSTables to some big hard drive. And this is even before you showed those libraries. I think you were showing it, LB, like, SSTable to Spark or something, or maybe it was ARPAN. But they can use the Java class for SSTable reader, and that's how they get data into another system. So they use the SSTable format to actually migrate data. And it's, as fast as it can go, right? You snapshot, you move it to a big hard drive, and then you just read the data. So it's interesting stuff.
So Rahul, just a quick question. So for migrating the SSTables, is there a OS dependency or Dse version dependency? Like you can only migrate from one particular version to the other. I know, of course, the version should remain the same, but from lower to higher version, is it compatible?
Yeah. So what happens when you do an upgrade is that part of the upgrade process is something called upgrade SSTables, which basically reads the old format and writes it to the new one. So, reading an older SSTable and streaming it to a cluster, it shouldn't be problematic, but, it's worth a try. But generally speaking, it's just, you can just run upgrade SSTables. So, you keep a backup of the old data, but you run upgrade SSTables, it'll rewrite the SSTables for you. It'll make it more optimal, right? Every time there's been a change to SSTables, they're much more efficient at storing the data, much more efficient at sorting the data internally. So then when you read the data with SSTableloader, it's going to be better.
All right. Okay. But I think for that also there'll be a compatibility matrix. Like I don't believe you can directly migrate from a lower version as low as 5.1.x to 6.8.x, something like that. I think there'll be an intermediate level where you need to take it and then upgrade it to the subsequent level.
That's the best. Yeah, that's the best practice, is to do it one. The best practice is you go to the highest minor version for that major version, and then you go to the next highest, version, a major version, and that process, hopefully you don't have to do it 3 major versions, but it's worth a try, right? Go from Cassandra 2.2 to Cassandra 4. I don't know if that'll work, but generally it's like, okay, go from 2 to 3 and then from 3 to 4. That definitely will work.
Right.
Yeah.
And can I ask another related question? It's not exactly related to migration, but in general, generic Cassandra question. So, I mean, recently in our environment, we faced an issue. In fact, today morning, that we are in the process of decommissioning a few instances from a cluster. So we have X number of instances, and we are going to X minus 1. And those instances were like decommissioned using node tool decommission. However, due to some patching activities, the OS got rebooted. It's all on AWS, and the EC2 instances were rebooted. Now, the decommission completed successfully, and we could clearly see that using the node tool status, we can only see the required number of instances. And like the other instances were like, I can say 3 or 4 instances were decommissioned. But after the instance, EC2 instance got rebooted from the Unix team, from the OS team, the instances were back. Like we could see in node tool status, all the instances are back in the cluster, even after decommissioning those. So we are actually still digging into it, but the auto bootstrap is set to false, for example. And we have a previous state, like it was not even part of the cluster. So how or where can we check, or what can be the possibility? It's a relatively lower version of DSE, but is it something to do with the version, like 5.1.11, due to application dependent?
Yeah, so if it was successfully decommissioned, okay, and you start it up, even if you say auto bootstrap equal to false, it will still connect to the cluster, right? Because it's talking to the same seed nodes initially. It may not stream the data, it may not copy the data, right? Distribute it, but it'll come up as long as it's in the same network. And if you're not using like node-to-node encryption, and or even if you are, you have a certificate there. Yeah, unless you basically change the seed nodes on that config, right, where it doesn't know where to talk to, every time it's going to come up, it's going to try to connect. The issue sometimes that happens is that you're trying to do a decommission, the node fails somewhere, and you want to absolutely remove it. You have to use assassinate, right? Node tool assassinate. And so let's say you assassinate that node. Okay, great, it's gone. You forced it out of the cluster. But then again, if it has the seed nodes, it'll come up and it will re-register.
Yeah, under my understanding so far, I've done the same because relates to the same, because the Cassandra YAML file has the same clusters. Right. The RAG-DC properties has the same. So I agree to what you're saying. But then in that case, what is a safe way of decommissioning? Because that means there's a risk that every time if OS is rebooted, even after successfully decommissioning, the node might still join the cluster. So what's the best practice to avoid it totally, like,
So let's say you decommission, right? And the node fails, just turn it off. You can always assassinate.
Or
right?
disable the service.
Yeah, go ahead. Go ahead. Ion said something, and the promote also added something. Go ahead.
I said you should disable the service. Make sure the DSE or Cassandra service doesn't start up automatically.
Yeah, that definitely. That is one thing. But even if we disable that service, the DSA will be stopped. And in that case, unless somebody manually starts the DSA services, it won't join. Yeah, that's a very good point, Pramod.
Yeah, so that's the thing, right? We've seen the situation where we disable the service, okay? And the nodes were turned off, and somebody needed Cassandra clusters, so they were like, oh, these machines have Cassandra loaded on them. Let's get them started. So what happened? They turned it on, and they're like, how come there's 40 other computers on this network? We only turned on one machine, you know, because they're doing node tool status. And it was because, you know, nobody had cleaned out. So if you really want to decommission a node, you know, if you're on the cloud, just throw it away. Like there's no reason to keep it around, you know? Or if you want to keep it around with the software, you know, move the config files somewhere so that there's no way it can start up with the same information.
Right.
Cool.
Perfect. Thanks, Rahul. Thanks, Pramod.
Yep. Yeah, Pramod, that's exactly what I mentioned, is that, you know, it'll join the cluster, but it just won't move information. But it can take definitely, it's part of the cluster at that point. Yep.
Yeah, I mean, unless explicitly a manual repair is performed, I don't think the data will be streamed across, right?
The data won't be streamed, but it will take writes and it will take reads. It will just, if the data is not present, it will reroute it internally. And if the data belongs there, because it's now part of the cluster, new data will get put on there because it's part of the ring at that point.
Right.
Now, there is a mode inside Cassandra which allows a node to come up but not store any data. Okay. And why do people do that? Well, they want to use that node for CQL operations. And that is actually what is used in the Stargate open source project, which has the REST API and the GraphQL API kind of co-located with that. Basically, it's, I forget what the name is called, but it's basically Cassandra node without any storage. It's part of the cluster, but it's just responsible for traffic. So there's a reason for people to do that. It just gives you closer access to information. Okay. Other questions? Well, looks like we talked about a bunch of cool stuff today. If there aren't any other questions, we'll go ahead and stop the recording. When will... I don't entertain Jay's questions anymore because he asks questions that have no answer.